Should we good there? Good there? Good there? Oh God, you got a way of inserting something so you have to type it overhead. Oh! 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 Cassie, you just backspace, and then you change the number and you hit enter.
Yeah.
Are we supposed to start number 5?
It's so much harder. Do number 3 right now. Number 2's up there. Number 1 and number 2. Table 1 and table 2. Table 2. All right, I'm going to start working on number 3 up here. Check your answers as I'm doing them.
It's actually 14.7. Up, actually.
1.5, negative 9.8.
So like it goes up and it goes back down. So it's like
What?
Which one?
I'm pretty sure that's
I'm trying to agree that it's I remember to check this.
never did it.
No, I know.
Yeah.
Oops.
Wait, with how
Yeah.
Oh,
So we're assuming a distance travel, not displacement.
Displacement. I want displacement.
Yeah.
That's what this equation does. Ooh, did that wrong.
4 seconds, you're back where you started. It's not 5 seconds. 3 is 4.7. This is at 2 seconds. Because it's like I watched the show the other day. I'm gonna throw myself
All right, folks. First of all, I may debate my answers, at least according to this silly little equation we made up that may have nothing to do with reality. 14.7, 19.6, 14.70, and negative 24.5. I heard several whoas. What's going on here?
the ball goes up.
Yes, ma'am.
How do you know that a maximum distance is 19.6?
Why are you asking me that question?
Because I don't understand.
I didn't say it is 19.6. In fact, this equation doesn't say that necessarily.
Oh, so it's just anything you want?
What do you mean anything I want?
I'm not sure. I don't understand.
All I did is I asked it, hey, where is it at 1, where is it at 2, where is it at 3? You tell me. And it turns out that it tells me that at 1, it's at 14.7. At 2, it's at 19.6, so it's still going up. At 3, it happens to be at 14.7. Now, I'm going to hit your question one more time a different way in just a moment. Okay? But I want you to notice something. The equation could care less about what you're doing. It'll keep track of where the thing is. It says it's going up, which we'd expect. It also then starts taking care of it's coming back down. At 5 seconds, it's actually below you, right? You throw it up, and then come back in. It's going to go past that point you threw it up from. It takes care of that for you. You want to do it yourself. Sorry, it'll do it for you. Because it's a displacement equation. Notice at 4 seconds, where is it? Where's 0? So where it started. So you threw it up, that's when it's going right past you. You throw something up in the air at 19.6 seconds, meters per second, you can expect 4 seconds later for it to come right back to you. And 1 second later, it'd be negative 24 below you. It's got room to do that. Now, your question was an important one, but does everyone understand the first part of this, which is really the most important piece? That in fact, this equation takes care of stopping and restarting. Now, you made the suggestion that you know you knew that the highest point is 19.6. How did you know that?
Because that's when it.
Well, what if I just didn't pick where the highest point was? I might not have. Turns out that is the highest point, so I was wondering why you thought that. Because I have to explain that now. And if you had a better way to explain it, I was going to go with yours. How do I know what the highest point is? Here's an interesting question. What does it do at the highest point? It changes direction and stops. Now, who said stops? Where's my stop person? Okay, why do you say stops? How do you know that? Because it changes directions. If it's going up, and then later on it's going down, someone knows it's got to be what? Stop. It's got to stop. Does it stop for a long time? No. It stops for a moment. So at some point at which we reach the highest point, it's going to stop and then change directions. Agreed? Olivia is correct. It does stop and change direction 19.6 because I said it that way. Because I'm a meanie pants. Let me show you how I know it stops. Let me show you how I know it's the highest point at 2 seconds. What if I were to do the following equation? V equals V naught plus AT. It's an extraordinarily testable moment, so I hope you all pay attention. Velocity at the topmost spot would be what? Olivia.
I don't understand.
Okay. When I throw something up in the air, what does it do at the very top?
Oh, so it's 0?
Stops. Its velocity would be 0, right? That's the point I'm trying to make. Does that make sense?
Yes.
So its velocity is 0 at the topmost spot. Its initial velocity was what in this problem? 19.6, agreed. Plus negative 9.8 because it's falling. Wait, is it falling while I'm doing this? Yeah, it is. Times the time. How much time? I don't know. Look what I can solve for. Solve for this right now. Figure out what time. You two, stop. Figure out what time is at the highest point. I hope you're paying attention to this part because I'm explaining how to do number 7 right this second. So it should be, it stops at 2 seconds. Now, why does it stop at 2 seconds, Olivia? Because I threw the thing up. I didn't hit the ground. Ah! I apparently did. I threw the thing up. Why did it stop at 2 seconds? It's the highest point. It slows to a stop and then starts accelerating downwards. Agreed? And because of that, I know at 2 seconds reaches highest point. So in fact, you were correct. At 19.6 meters is the highest point. Mostly because I set it up that way. But when you do the math, you realize that t equals 2 seconds, it stops. And the reason why it has to stop is because it's changing directions. It's changing directions. That's the highest point. We got that? Huge concepts all in a row, right there. Wait.
So wait, I'm still really, really confused on number 2. Can you just go through it really, really fast? It's like I don't know why I'm not understanding it.
Can you phrase that in a better question? What if there was bothering you?
Oh, okay. Never mind. Figured it out. It's getting me a lot of trouble.
That was the perfect question I just asked there. Wow, look at that. Okay, so
Well, the question has the answer.
yes. Are you good?
Yeah.
Okay, so the equation takes care of this. Now, there's 2 other things I need you to get right now because they're also very, 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 very important. Okay? The 2 things that are very, 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 very important are this. Item 1. At the top of the flight, the ball, bullet, airplane, whatever must stop if it's falling. Because it's going to change directions there. So that's something if I throw, say, Bob goes outside, throws a rock up in the air, how high does it get? Answer, solve for where it stops, then find the displacement at that time. The second one is this. How fast is it going when it passes back by your spot? Hey, we got a perfect opportunity. We know its speed is, we know it's passing by our spot here. What is its speed? How am I going to figure that out? 4 seconds it's going past me. How am I going to figure out what its speed is?
Plug 4 into 1.
Plug 4 into this equation. Somebody do that fast. Everybody do that fast. It's got a displacement of 0, which means it's right there again, right where I left it, my hand. I want to know how fast it's going when it passes by me. What? You put a 4 in this equation, what do you get? No. No. I put a 4 in this equation, I can get that. Hope not. We got Natalie? Negative 19.6, which means if I throw a ball up at 19.6, what's it coming back down? When it reaches the same spot, it's 19.6. So when Bob throws a rock outside and hits him in the head, how fast is it traveling? Never fast he throws. If you throw it like this, it doesn't hurt. If he really hucked it, it's going to hurt. Okay? First phase of the Iraq Gulf War. The Iraqis claimed that we shot a bunch of their people on top of their buildings. That they had some anti-aircraft gun people on the roofs, and we strafed them. And our military said, no, we didn't strafe anybody. Why would we shoot anybody? That doesn't make sense. We have bombers. We didn't shoot them on the roofs. Said, no, look at all these people in the hospital with bullet wounds. Said, ha, you shot them. Nearly killed them. What happened?
They just shot in the air.
Yeah, our stealth bombers were at 10,000 feet dropping bombs. They were shooting up in the air and trying to hit them. Yeah. How fast did you blow up at 300 meters per second? How fast did you hit your helmet? 300 meters per second. Neglecting air resistance. Ow. The other bit of proof, by the way, the one that was the really damning proof is that those stealth bombers carry 400 millimeter rounds. Sorry, not 400, 40 millimeter round. 40 millimeter round is this big a round and explodes when it hits something. There's a definite difference. Definite difference on the human body. So, that's what I'm saying. It's not. You're not going to the hospital to get hit with a 40 millimeter round from a stealth bomb. You're not going to the hospital. They're doing that dental records thing to try to figure out who you were. Is what happens. Okay. Good. All right. Because displacement, then velocity. They're flight calculus. Don't look at it. Although I explained this in class in great depth. They're finally getting to there. Oh, hey, you can use calculus. Yes, you can. If you really want to at any given time. Okay, so what is the speed of the highest point? The speed of the highest point is 0. That's always going to happen when I throw a rock up. Does this make sense? Yeah, because it got to change directions, right? Flipping it over. Let's start handling some real problems other than this chart stuff. Bob drops a lead ball off a 40-meter tall building. Why lead? I don't know. We want air resistance to be so small it doesn't matter.
What is air resistance?
Yeah, you have to do about second-year calculus, and then you'll be ready to deal with air resistance. The C kids have to deal with it. You will not have to.